Hello guys, I'm Shikai from SMK from Australia. So today I'm going to present about the topic 1.3 forces in equilibrium. So what is forces in equilibrium? Okay, let's have a look. So the definition in forces in equilibrium is an object is said to be in equilibrium of forces when the forces acting on it produce a zero resultant force. Okay, so basically, when we're doing the questions about forces in equilibrium, we will face a question that is like this. Okay, object which will draw in middle and is hanging on wall or something else. So in this question, we can solve it by using the method triangle of forces. Okay, so the transition is in like triangle type of shape. So this method, I will tell you and explain about this method in just a moment. Okay, so let us look about example. Okay, so this is the question. So figure 1.26 shows a stationary lamp hanging from two strings. Okay, two strings. Okay, first string and the second strings. The tension T, yeah, this T, okay, is 8 Newton. Yeah, it's stated here. And the string is inclined at an angle of 60 degree. Yeah, here 60 degree inclined above the horizontal. Yeah, horizontal as shown in the diagram. Calculate the magnitude of the tension P, and also B is weight of lamp is W. Okay, so we want to calculate P and the W. Okay, these two magnitude. Okay, so okay, how can we solve these questions regarding these forces in equilibrium? Okay, so our method, the first method we are using is resolution of forces. Okay, resolution of forces that we already learned in the previous topic, which is 1.2, resolution of forces. Okay, so basically, we should know how the resolution of forces. Okay, so in this question, okay, I have extract out a diagram. Okay, this is the information that I have extract out from these questions. So, okay, so this dotted line over here is T, okay, which is 8 Newton, okay, in inclined at the angle of 60 degree. So we want to find P and W, okay. So the we find the Tx first, yeah, Tx first, okay, which is this line, which is this line. So how can we find this line? Okay, so as we told, this dotted line is 8 Newton. So in 60 degree over here, so we need to like compress down from the original position. So it's compressed 60 degree, so it's 8 cos 60, 8 cos 60. So we can find the Tx. And sorry, and for Ty, as we need to push it up for the y-axis to the y-axis, so it's 8 sine 60. So 8 sine 60, you need to push it up. Okay, so 8 sine 60 to find W and P. Okay, so how can we find this? Okay, this is the diagram that we have extract out. And okay, A, the resultant force of the horizontal forces is equals to 0. Yeah, the definition of forces in equilibrium, the resultant force must be in 0. So yeah, we find this Tx just now, 8 cos 60. So this side is 8 cos 60, and P also is in 8 cos 60 because the object is in equilibrium, so it's stationary. So 8 cos 60, we press calculator and we get 4 Newton. Okay, is the answer for the part A. And part B, the resultant of the vertical forces equals to 0. Yeah, same. Okay, here above is 0, is 8 sin 60, and then down is 8 sin 60. So it's equal. Okay, so the weight of the lamp W is Ty. Okay, 8 sine 60, which is 6.93 Newton. So this is the answer for this example, and this is using the method resolution of forces. And I will show you the second method, which is the method 2 is scale drawing of the triangle of forces, as I told just now briefly about the triangle forces. So let's look about this method. Okay, this is the question just now. It's the same question. And then step 1 is choose a scale. Okay, choose a scale. Okay, we need to choose a scale to enable us to draw this triangle. So we choose 1 cm because 2 Newton. Okay, this 8 Newton right here is T, and then 60 is over here. Okay, draw the force T with non-magnitude and direction. Yeah. Okay, step 2, draw a vertical line downwards representing W and a horizontal line to the right representing P to form a triangle. So yeah, this drawing down here, W, okay, this is the parallel with this y-axis. So there's another important concept in this triangle of forces. In triangle of forces, the arrow here, the head of the arrow must touching the end of another arrow here. So it will be like a triangle over here, form a triangle. It cannot be like the head of the arrow here touching another head of the arrow here. So this is a wrong concept of this. So let us look about it in next step. So step 3, measure the length of the sides of the triangle. Use the scale you have chosen to calculate the magnitude of the force. So take out your ruler, okay, your ruler, and then you measure it that you have by using the scale given. And then the scale you will for P here, you will find 2 cm. P you will find P is 2 cm. Okay, so 2 cm is not the correct answer. You must find the cm in you must find the answer in Newton. So you must times 2 because the scale is 1 cm equals to 2 Newton. So 2 cm is equal to 4 Newton. Yeah, times 2 is the answer for P. And then for the weight of the lamp, W, equals to 3.5 cm. It's over here, 3.5 cm. Okay, also need to times 2 Newton to enable us to find 7 Newton. Okay, there's a big difference of the answer in by using method 2 and method 1 for the part B. Yeah, so this is the method we can use to solve the question about forces in equilibrium. So the first method is a resolution of forces, and the second method is triangle of forces. So we can use these two methods to solve the question. So that's all for today, and hope to see you next time. Thank you so much. Bye bye.